Okay, hello everyone. After the break, I had an experience in a corporation that basically many of the engineers came from C domain. The effect of that is that a lot of code, a lot of interfaces have a lot of pointers inside. With having a lot of pointers, we have a few issues, especially when working in validation. We found out that like more than 2/3 of our bugs submitted are things like stability related, buffer overflows, null pointer references, and any other stuff that's related with it. Also, when we started to use things like static analysis, like Clockwork or other tools, we found out that we have like hundreds of issues reported by the tool because they claim that the pointer here can be null and we didn't provide a check for it. Providing a check may be expensive, so they are not, and people say that's false positive because this function is never called with a null pointer, for example. But you never can know this. When I changed my employee to another company, the first thing I did, and the first commit I submitted, was remove all the pointers from the source code. Right now we have a huge software working in production for a really big customer after 2 years, and through all those 2 years we nearly didn't have any crashes and any problems connected with stability and security. So I may say that those things that you will learn here are really important, and they are really they are proven in the experience proved, like in the production also for huge projects. So yeah, let's continue and see what's there. Basically, what is a pointer? According to Wikipedia, a pointer is a programming language data type whose value refers directly to or points to another value stored elsewhere in the memory. Yeah, so basically we use an address that describes us exactly where data is located in the memory. This is the official definition. My definition is exactly something a bit different. That pointers, due their ambiguous nature that we will learn in the future, in a few slides, are the source of most problems we see in our C++ code. Lack of understanding between the designer of the interface that was providing the function to the users and the users themselves that cannot interpret the intent of the author led to many different problems here. And those problems can be like crashes, asserts, memory leaks, and others also. So basically, pointers misuse leads to things like null pointer dereferences, yes? Resource leaks, buffer overflows, which results our product to hang or to crash. And these are really visible by the clients and then reported by clients by stability issues or security issues. If someone can use this vulnerability to, in fact, exploit our software, yes? And subjects like stability and security cannot be ignored right now in corporations. They are really, really important. And I know from experience that even higher management is able to sacrifice some of the performance in order to provide those to the clients. And even not talking about huge commercial people, I would like to see how, maybe show of hands here, how many of you would prefer for your, for example, cell phone to work like 5% slower, but not restart every hour because of a crash. Yeah, exactly. I also like most of the audience. So we as users are also really frustrated where we see a blue screen in Windows, or we have to restart application or restart our cell phone because something bad happened. And you will learn here that using pointers is one of the best friends of those undefined behaviors. And that's why I, in fact, provided that presentation. So what is the problem definition here? Let's assume that we have function A that takes some pointer, returns some pointer, does some processing here, and as the result returns function B. Yes? So you have function B that calls C and do some other processing. And it just adds and adds and adds this up to here, when finally we dereference the pointer. Do you have maybe such call stacks of the arguments are passed and then passed through to some lower level of your software and then dereferenced somewhere? Probably you have, yes? And what you do, what you do here to somehow protect from such problems? Asserts. Very good answer here. So basically, you assert at every place here, yes? As we learned yesterday on the undefined behavior talk by Andrzej Krzemiński, it will fool your optimizers, your static analyzers, because they will no longer provide you an error that there is a possibility for no pointed references. Besides, assert is working on a debug mode, and this is exactly the mode that we are testing, yes? Client will see a crash if something clicks. Those if statements are not in the code after product release. Client will see them and will have to deal with every possible outcome that your code provides to him by referencing something that is null. So other possibility here is to put something in runtime. But on which level you would like to verify that pointer? Doing only at the last one, or maybe on every level? You never know how this function will be called. If there will be no other CC function that will be calling D, you don't know exactly in which place is this happening. So you don't know which is the first point of verification. So you cannot assume that every other is already verified. At the end, probably you have to verify, but still, you can be also dereferenced on other stages, not only on the last one. And we have here branching, and this branching can provide some performance hit, yes, because on every place we have to branch. This is also bad. Probably we are not using that at all because of some performance reasons, because we care about the performance. So let's talk about this interface a bit. What can you say me about this? What it does? I'm the function author, I'm the architect of this interface, I provided you such function. What are your ideas, what it does, how to use it? Yes, so I've heard that we can have probably null pointer given as an argument and expect probably null pointer on the return type. Yes, it's possible. One of the many possibilities here. And what's missing here in order to know what it does? Names, yes? Okay, I give you names. Is it better now? Yeah, we don't know if name is an input or is it output or other logic, yes? Do you know what the name is? Maybe it's allocated on the heap, maybe not. We don't know what is ownership exactly. We don't know if it has to be freed or maybe it's stored somewhere for later, or maybe the user should call free after calling this function. And in fact, do you know if you can iterate over it? Is it an array? There are many different problems here, yes? So let's think about this interface once again and verify how much we can, in which cases we can use this interface. Is it assuming that underneath is a valid implementation of this function add? Is it a valid usage of this interface? Like we have here this function add, and we just allocate something like the name, and then we expect that we'll get something that is not null, we assert on this null, and then we dereference something for some processing. Excuse me? It depends. Person or the function add?
Person created by the add function.
Yeah, so basically it may turn out that the person will get ownership of the name, or the add will just free this and put the name maybe in a different container, like a string or something different, yes?
Same for a person.
Yeah, but as I assumed, let's assume that add is implemented correctly.
Side effect that it can put the ownership of with returns pointer into some static container, so it's not clear from that interface that we now own with person. It's not some objects which handled by some other framework.
Yes, exactly. So, but as I said, let's assume that the name, person, add are implemented correctly. Is it a valid usage of the interface? Can you imagine such implementation of add, person, and name that it will be valid? I assume yes, yes? Okay, so what are the potential problems with it? As you said, there is no information about the ownership, yes? So basically,
potentially we have a leak of this name object. And potentially we have a double delete.
Yeah, exactly. Or delete of something located on the stack somewhere. Okay, this is another case. This is once again the same function, and we are using this differently. Is it a possible valid use case for that? We have name here, we pass it by a pointer, yes, and get p that this time can be null, and if it's not null, then we process stuff.
If we'll use the same implementation as the previous one, it won't work.
Yeah, if you use the same one, but but we assume that there's implementation that can fit into this interface, yes, and it can be even worse. We may have such a thing, but this is still pretty trivial. Let's look on the fourth example, which may be even this. Is it still a valid usage of this interface? We have like an array that's terminated to a special tag, like empty string, and we put it to our add that takes a pointer, and we receive an array, in fact, that we know will be of size that minus the stack at the end, because it did something like a simple transform on the input. I've seen too much of the code like this in my career, and that's why things like Clockwork get really crazy when they see naked pointers. And once again, we may have here some memory leak that especially if this function is not exception safe, because it may throw from process and then delete will never happen. Okay, so you have those 4 cases. Let's now play another game and try to find out which implementation of function add will address this use case. So this is the first implementation. Which of the usage such an implementation will cover properly? Second, yeah? Good. Another one. Fourth? This fourth is an array, and we are looking until the pointer is empty tag, yes? So it's probably fourth, yeah? Okay. And this one? First one. Yes. So this one will be the last one, yes? This one is using some algorithms, is using findIf, begin, end on the container, and it's looking for a person with lambda, and returns some functionality here that is non-trivial. So basically we have returning null if it's an error, but we are also returning a null when we found an element in the container. And in other case, if the container that the entry in the container was not found, we just return and place back this element to the container and return the pointer. So basically this function returns us the pointer only if it puts something into the container, yes? Which is totally not obvious from the interface. Okay, can we do better? This is our interface that you're working on all the time, yes? Can you tell me about this interface? Especially, do you know how to use that function and how to implement that function, having this? Exactly. We are passing an ownership to the function and receiving an ownership from the function, yes? As you can see, we didn't change too much, yes? We just provided information, not only the information like the function name or the argument names that were totally meaningless for us as it turned out. We added types that replace our pointer with some abstraction because we are using C++, not C. And so we can do it. And right away you exactly know what to expect from this function and how to use it. And this is exactly the approach I would like to propose you through the examples, because that's a great change for really for the stability of all the software you will write. So basically, this is the old implementation of the case for this interface, and now you have a new one. This is how you replace stuff. It's maybe a bit more verbose in the first case, but it's for sure much more safe because it's exception safe and so on, and you exactly know the intent of the architect that was provided in that interface to you. And also the usage here is not much more complicated. And look that we don't have to care anymore about the manual deleting of the resources. Moreover, this one started to be exception safe right now. Another possibility. Can you tell me about this function, what it does?
It accepts a probably absent, probably null name and return a reference to an object handled by somewhere else.
Yeah, exactly. So we know what to expect, yes, just from the declaration. We don't need any documentation, any I don't know, docs again generated for this. We know exactly from our declaration what to expect, and this is the power of such interfaces, that you don't have to write any documentation on it. In fact, if you have to provide documentation with user wording or how to use your interface, then you did probably something wrong. I expect that there should be only description about the function of what it does exactly, how it operates inside, how it changes the state of the application, and not how to use it. Yes? So let's see how it works in our case. This was the previous implementation. This is the implementation with this check. Yes, we can have possibly null or empty optional value of name. So, and we now emplace back to our people container. We emplace the name only if it exists with move semantics. And in other case, we just provide anonymous as a default value. And then we return always the reference to people back, so we know that it always provides some data. So basically, this null pointer here was not needed because someone didn't understand our intent. Because it will always provide you the data from the function. And the usage of it is trivial, yes, right now. You don't need any asserts. And you may even create this name in place here, because it's passed by value. And here you had to provide L value like a pointer. So you should define it earlier on the stack. Okay, so let's try another one. Do you know what to expect from such interface?
Not exactly, but mostly according to std, behavior of std functions with bool means that is it new or not. So was it added or it just returned an existing value?
Yeah, so this interface may look somehow strange, but there is an example of such interface in the standard library. Do you recognize maybe this pattern? Yeah, map insert, yeah. You can map insert or set insert, basically. Those functions can tell you that if the entry was already there or it was put by your function, yes? So basically, and in the other parameter you provide information, it was put to the container or not. So if you remember the other implementation, we had here two possibilities handled by the same null pointer value. Either there was an error and we returned a null pointer, or we didn't find something or we find something in the container, so we return also a null pointer. As in this interface we couldn't handle this otherwise, we decided to do such a trick. Right now we can do better. We can look for this name in the container, and if we don't find it, we just return a false as a good argument. If you find it, we return this iterator, the data pointed by the iterator, and put false here because we didn't insert anything. Look that we also don't have handle any error case here because we don't have a pointer. Yes, so this case is also not visible here, not needed. And then if something was not found, we just put it into the container and return the reference to it with the value true, saying that we inserted something. And in fact, valid use of this interface is like that. We want to process something only if we put something to the container. With that, it was not that visible that is exactly the intent of the author with this null pointer. And making those interfaces even a bit bigger, like putting reference and a bool, as long as it's of size of 2 pointers, let's say up to size of 2 pointers, it's still good to pass everything on through the value. It's considered to be cheap to copy, like string views, like spans, and other types you have in standard library. Those things should be passed as values and not the reference types. Value semantics is really great, and optimizations that are possible with using value semantics make it even much faster than passing something by a reference to the function, where there is possible aliasing and other possible problems that just compiler has to give up its optimizations practices.
Wait a second.
You mean here?
Shouldn't it be 1 instead of bool there?
You may, with std-get, you may either query data by index or by type. I think it was added in C++ 14, but I'm not sure in which case it was added. But with std-get, you can query with both. In fact, right now I could even use structure bindings to get data from this interface, because this is what's allowed with C++ 17. So there are many possibilities to get data from the tuple. And in fact, I prefer, if it's only possible, to use types here, because then I'm free to refactor, like order or put something in the middle, and I'm not having any problems later on with the rest of the code. So as long as you have only one instance of a type on the list of tuple, because you may put more than one, then I prefer to get elements by type from the tuple, not by index. Here I got by index just to show that there are two possibilities. Okay, so let's look on the last example here. This time we have such interface, and do you know how to use it? Is it explicit that it's an array right now? With C++ 20, probably you will be also able to use things like span, that are things like called array view. These are the same exactly. In fact, it was named array view and then was renamed to span after some discussion. But the idea is similar. So this was the implementation of this array approach, which was pretty inconvenient and let's say not intuitive. That this interface can be abused like that, and in fact that you can expect something from this. And this is exactly how you can implement this with the new interface, like std vector. It's much slower, much safer. You don't have any buffer overflows. It's not possible that you will try to iterate over the one element like a pointer, because I've seen a lot of iterations over a single pointer stuff. Like people assume that it's an array and it was only a dynamically allocated memory. And also I've seen a lot of dereferences like only star, they dereference on an array type that was passed to the function, because people didn't know that it's array, so they just dereference the first value and they thought they are done. With such interfaces, you provide explicit information to the user that it's an array. You provide explicit size, and that's always connected to the pointer. So it's really easy to use. And with features like range-based for loops, it makes it really handy and secure to use it. So basically, as I said, those simple tricks or those simple practices that I presented to you really proved in the practice. I really recommend you to consider removing most of your pointers in the interfaces. Pointers in the implementation, it's another stuff. Sometimes it's needed because you, for example, cannot reassign the reference in structure member or class member. But for interfaces, pointers are really not needed. And they have so many different faces that it's really easy to misunderstand each other. So I don't see any excuses right now, especially right now that we have this STD optional class. Like I was starting to providing the similar talks, or at least some ideas from here, like just before C++ 14, because I was sure that STD optional will be there. I already put it as STD, not that experimental stuff. But it turned out that the experimental was removed right before the standardization of 14. Now we have it in 17, so right now there are no excuses. We are not doing C. This is how C is doing. So basically, if we have mandatory big value, we have this. If we have output function argument, we have this. Yes? If we have an array, we have this. It's much different, yes? The name is different. If we have optional value, here you are. Ownership passing. Okay, tak? Yeah? So now let's think about this a bit different. How would you implement in C optional dynamically located thing? What would be interface? Or dynamically allocated array? What would be interface of it? Or maybe I would like to pass an ownership of optional value that's an array. Everything is the same, yes? It's not only like you consider this, either this, either this. It can be also multiplexed with each other. And finding out what was the author's intent is really hard without any reasonable documentation. So we are living not in C, yeah? We are living in C++, so there are no excuses to be verbose here. So when you are passing mandatory big value, pass it by the const reference with const, yes? Because it's an input only argument in this case. If you want output only argument, do it without const. Be explicit. When you want to output function arguments, do it by value. In fact, the return value optimization, so-called optimization until 17 right now is mandatory. So RPO right now will be done as a mandatory step, even if our class doesn't provide copy constructor or move constructor at all. But it's only return value optimization. If we are talking about assignment, move semantic is our friend. It turns out that returning by value is often much better for code complexity, for the maintainability of the code, and also for the performance. You can try to measure that. I measured that in many cases, like this proves even better, or at least as good as passing things as argument to the function. If you want to return more than one thing, do not return one thing by the return value, another one by argument. Use a tuple or a pair. Yes? As long as those are pretty small or easy to move, it's still not an issue. If really needed, yeah, go with that, but still use a reference, not a pointer, yes? Array. If you want to pass an array, use any container you like. It may be only container like vector, it may be deck, it may be even C-style array. However, encrypting this in a keyboard to pass C-style array via the reference is not that easy, and it's not that easy to understand, but it's still possible. You can use, also will be able to use the span from C++ 20, and probably I hope that will be decent implementation on the GitHub soon, so we can start using it before the standard actually comes. If you want to pass an optional value to a function, use std optional from our friend Andrzej Krzemiński, who is presenting on this conference. It's really a great tool, especially for small sizes. If it's huge size, then you may still consider doing pointer. But this is the only place when you use pointer in the interfaces to express optionality. So basically, if you see a pointer, you have to assume that it may be null, always. And in such cases, you always provide if statements to verify if it's not null pointer. There's no excuse to not use if here, because you are exactly by this coding practices and techniques, you know that you can expect only optionality via pointer, nothing else. Ownership, use unique pointer. Do not try to use shared pointer everywhere. If you are wondering why, I recommend you looking into my other talk. with such constructs, we can explicitly say exactly what we expect from our users, and our users will exactly know what we provide to them. And as long as you write such function and you feel like you don't have to write any documentation for it, it means that you've done a good job with that. I really recommend you to follow this. With C++20, we will be able probably to extend it with so-called contracts, which will add even more security and safety to our interfaces. The contracts will be a part of the signature of the function, so it cannot be omitted. You also will have problems, or you have to obey those contracts while passing things like function pointers. If you are assigned a function pointer to a pointer, you will have to have a function that's at least as strict as the one that was declared. So, do you know what to expect from it right now? I don't have any names. I don't have person. I don't have name. I don't have add. I have only this first syntax I provided to you. Bu fu a, without any names. You know what to do with it? I hope you do. Yes. Names are even not needed here, in order to provide good interface. And one more spoiler for the upcoming standards, like C++17, that we have already standardized. It's still not published, but we expect it to be published this year. And but it's already it will not change at all. You can just grab the latest draft and assume that it's there. And most of the compiler, in fact, implemented most of the features already. And C++20, that we expect to come soon, you will be able to do different stuff. In C++4, that was the things how you was doing things until the C++14, from ANSIC prehistoric stuff to pass C-style string, yes, with known length. And it often happens that the size and pointer are not going together. Somewhere you will lose something or will overwrite something, and then you have problems. It's better to have things tied together, yes? You could also, of course, here use things like string, but then you may sacrifice something like an allocation. I just didn't want to provide here the string because you would say that's not exactly the same, yes, because it costs us in performance. From ANSIC to C++14, for arrays, you had to use this. In the future, we'll be able to this string view. Right now, you can use it. It's available in every compiler I know. In the library, even without experimental namespace. And for C++20, we standardized right now something called span, that was earlier known as array view, that basically stores a size as a pointer. And string view also, in fact, as an internal implementation, stores a pointer and a size. So these are always in sync. They are always updated. You pass them as one value, and you don't have any problems with that. Takeaways from this. I will probably finish a bit earlier. I assume that's not bothering you. If yes, then I'm really sorry. But this is what I had ready for today. And in fact, I wouldn't like to extend it much more because I just want this point to be clear enough to remember. C++ is a powerful and versatile tool. Yes, it's a Swiss Army knife. It's not like a shovel of C. We have strong type systems, better abstractions than C. We have templates. We have great C++ standard library, and it will become even better with years. We have to use them. Do not start and think like C programmers anymore. If you have guys that maybe in your companies do not agree with you, try to challenge them. Try to provide some data. Maybe ask them to verify their code with Clockwork or other static analyzer, and show how many issues those tools generate for pointers, because the pointers can be interpreted in so many ways, as you've seen. And with that, I finish, and I'm ready for questions.
Thank you, Mateusz, very, very much for this additional presentation, full of interactions. That was really a great thing. Yes, we are ready to... Oh?
So, hi, thanks for the talk. I have a question about returning multiple values from a function. You showed us tuple?
Yeah.
But do you really use it, or do you also use a struct with the members of the, like, because when you use output parameters, you have a name of the output parameter. If you use tuple, you kind of lose this information. You have, for example, I've seen a function with a tuple 4 integers, and that's sort of really cryptic, like what those integers mean. So maybe is it, because I don't know about structure bindings, I haven't used them yet, but I think structs can also be unpacked from, the structs can also be unpacked into structured binding, so it kind of makes no difference between, sorry, is it me? It makes no difference between struct and a tuple when it comes to structured bindings. So do you use tuples or
I think that's me.
Or structures?
Yeah, basically, if I would return things like, is it microphone? Or me? I don't know. Yeah, so basically if I would return something like 4 ints, I wouldn't use tuple for sure, yes? I prefer to use pairs of tuples only if it's used in one function. And also I wanted here to be consistent with the standard library interface, so you would have an exercise to find what it is similar to. But if specific return value is used like through all our application and we use it like from 10 different functions, then for sure I would provide it as a structure. In fact, we had exactly the same question like a week ago in Albuquerque, where we were thinking about our next standard. There is a class, I think it was called, it was flat map. Flat map that basically uses 2 vectors underneath or other containers that you will provide by template parameters, just to map things between elements, and you'll be able to extract them from the flat map container. Just to extract them, and you could play with them by your hand, and for example, possibility put them back there. And we just decided that the flat map as a default should return iterators or things that will be just a pair, like you have to iterate to first and second, like with typical flat map, typical map. But for flat map, those 2 containers will have to be returned as a structure with named exactly members, saying that's a key and value. So even C++ standard library consider this a better practice, and basically probably right now the map will not have a pair, but also named interface. But to be consistent, even in the flat map for iterators, we'll see first and second. But for the returning of containers of keys and values, we'll have dedicated name structures.
Hi, nice talk. I have a question, more of a doubt maybe, about the out parameters in functions. You provided one nice solution with returning the tuples, but that might not work in some cases. Namely, if there is a template, function template, or anything related to templates, really, when I'd like to have, say, automatic template deduction and pass the parameter, pass the type from the parameter of the function, then the only real reason, the real option you provide would be the non-const reference, right? But if I use that, then there is the readability problem, because at the call site of the function, you can't really distinguish between the function that would change the parameter or leave it intact. Just wanted to say that maybe, what do you think about the approach that maybe instead of using non-const references in these cases, how about using const pointers?
I'm not sure if I understand the question. Does it mean that you would like to not provide arguments for the template and instead depend on argument deduction of the function?
Yes, exactly.
I don't know if that's a target worth pursue in order to sacrifice the interface. So basically, the return value is only put as an argument in order to be deduced, yes? It may be better just to depend on the user that it will be providing the return type in the braces, and then all other arguments that are input to the function will be deduced. And you may also, on the other hand, look into Upside library that was released by Google like a month ago on CPPCon. That was official announcement of it. They have a, I think it's called StreetCut functionality utility that basically StreetCut or StreetSplit, I don't remember exactly, but it basically can detect the return type of the template. Also make the automatic time deduction. It's implemented by implicit casting operators. So this is possible to detect the argument that, or the return value that has to be returned from the function. So basically, what they do, they are able to put outputs to any type of the container. You will kind of provide vector of string views, or I don't know, array view of strings. They will be outputting exactly that what you requested from them, and you are not providing this as a template parameter. It's possible. You can find it in Upside how to do it.
That would be cool. Thank you.
Thank you. And there was a case too when we returned tuple with reference, and there was DQ as a container.
I think it was case 3, yes? This one.
Yes, this one. So what if some guy in our company will decide that DQ is not pretty performant and will replace it with vector? And then we'll return this reference to actually elements that might be then invalidated, became invalid. So maybe we will go farther, and there should be some return by value, utilizing of move semantics.
Yeah. So basically, yeah. I assume that that's not a question if I should prefer pointer instead of it, because this is exactly the same issue. Basically, this is the question regarding which container should I use to do my work. Yes. And we assume that the pointer is stable in the container operations. Deck provides us such things as long as we insert stuff and not delete anything. But you can use other containers if needed. Yes, you have to choose a good tool for a job. You can. It's really hard to say it, but you can use list. But also you can think about maybe some modern new designs, like for example PLF Colonia I was referring on my other talk. It's exactly the structure that is a container looking and working a bit like allocator. So basically the pointers to it are also stable, and it's really fast to iterate. It's nothing faster on the market.
Yeah, I mean, but to protect from kind of implementation details, you told that we should design good interfaces. So I mean, if we get rid of this reference in our interface, maybe that actually will be better. How do you think?
Yeah, if you want to return the copy, but maybe you would like to modify it somehow with the function process, yes? So you want to have something. You may consider returning an iterator, yes? But
yeah,
instead of reference. But still, I just wanted to be consistent with this pointer semantics, yes?
Yes. Okay, thank you.
Just raise your hand up if you have any question. Yes.
There was a slide that you don't use std size from C++17.
Do you remember
from the beginning? I don't know.
Size here somewhere?
Yeah, before. You just use the old size.
You mean this
size of this one? Why don't you use std size?
But because this is old evil C style code with pointers. Yeah, there is an std size non-member function provided by the C++ 14, I think, or 17. Yeah, maybe 17. Yeah. And there is also begin and end for this non-member. There is a data also member there. So it's much better to use those, especially than and as I mean those non-member functions, as opposed to member functions, because then you can work like with those C-style arrays too, and any other interface you will customize with maybe your own library also will work with it if it's customized properly.
I have a little bit question, because you got me hooked when you said that your first commit after changing the employer was to get rid of all the pointers. How big was the code base and how big was the change and how long did it take? And did you use some automation or did it by hand?
No, when I in fact joined this customer or this project, it was developed like for 4 months by 3 employees, so it wasn't huge, but still it was a significant amount of work. Like I did it for 2 or 3 days to just to replace all the pointers and make sure that I did it right. So it wasn't like just use any tool or did it in 15 minutes, yes. But until then, we didn't have any stability issues or any security issues, any crashes in our software. We have some possible issues right now, and we still don't know how to solve them. But this is basically the other thing that was invented by C++11, so use after move. And for that, we don't have right now a good answer how to use it. Compilers are not much helpful in helping us with that. Even if they see like move and then usage of the variable in the next line, they're not producing any warning messages, which I think sucks. So basically, those are the issues we have. But with pointers, with crashes, array overflows, null pointer references, memory leaks, nothing.
Are all questions answered now?
If there are no other questions, thank you very much. And I hope we see each other next year.
Yes, yes. Thank you very much. Mateusz Pusz. Thank you.